Hello again, and welcome to another edition of Algebra 2 Notes with Miss Faust. Hey, I heard the other day they did a study and found out which state has the most math teachers. Do you know which state it is? Massachusetts. Okay, so today we're going to be looking at lesson 715.2. This is the last lesson from Unit 7. And our essential question is, how do I graph a logarithmic function and transformations of a log function? And the thing that we're going to use to help us in this is the fact that logs are related to exponential functions. So when we think about graphing a log function, for example, y equals log base b of x, what we want to do is we want to think about the corresponding exponential function first. So that's why I moved that one over a little bit. So the function we'd always look at first is b to the power of something, b to the power of y equals x. So what we'll do is we'll graph b, we'll switch those, and then we can do the inverse. And when we do the inverse of those, which means we switch the x and y values, we will get the log function that we're looking for. So that's going to be the big idea when we do these, and then we'll look at how transformations work. So if our first function was y equals log base 2 of x, the corresponding function that we'd want to look at, and again this is going to help us get the values for y equals log base 2 of x, would be 2 to the power of x equals y. So if you think about what the table would look like for that, we don't need too many numbers, but we'll put a few in here. So if you do 2 to the power of -1, you would get 1/2. If you do 2 to the power of 0, you get 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. I know I did those fast. That's because we've done lots of exponential functions. And you can always grab a calculator if you need to see those. So then, for the log function, we're going to switch the x and y values, and that'll give us our table for our log function. So x and y equals log base 2 of x. I just didn't have room for it all on one line. So here we just switch these. So this is 1/2, 1, 2, 4, and 8. That's my column of y's. And then my corresponding values over here become -1, 0, 1, 2, and 3. So what we can do then is we can go ahead and graph those, and notice here none of my x's are negative, so I don't need to make my x's go negative, and my y's don't get that big. So I'm just going to do a graph like this. I'll start it here. I'll go like that. 1, 2, 3, 4, 5, 6, 7. Yep, it's going to just barely be long enough. And so here we have 1, 2, 3, 4, 5, 6, 7, 8. -3, 3, looks good. So I'll do this first one in green. 1/2 and -1 would be about there. 1 and 0 would be there. 2, 1, 4, 2, 8, 3. And when I connect those with a nice smooth curve, it would look something like that. So kind of similar to, well, you should be able to see a relationship between the exponential functions. Remember the exponential functions went up like that. So again, if you think about that reflection, we get the inverse, which is the log function. And let me just write up here that these are inverse functions, because that's the big idea we're working with here, switching x's and y's. So when we look at this graph, there's a couple of important things to notice. The domain for this, notice that the smallest x ever could get to is 0, so the domain is just x is greater than 0. The range in this particular one is all real numbers. The y values could be anything. This has a vertical asymptote instead of a horizontal asymptote. So it has a vertical asymptote at x equals 0. And it has a couple of reference points. Those reference points are right here and right here. So that one is at 1, 0, and this one is at 2, 1. And so when we look at transformations of log base 2 of x, it's those 2 points that we're going to move in order to find our new ones. So I just want to show you quickly what one more looks like, because the thing about logs is that different bases can also give us different graphs, just like different bases and our exponential functions give us different graphs. So if instead of log base 2 of x, we had, for example, log base 10 of x, and that was our y. So before we can make our table for this one, we need to think about what the inverse function would look like. So from there, let's see, the inverse of that would be 10 to the x equals y. So if I make my table for that, y, I'll do the same x values. And this one's going to have a hard time fitting on a graph, but we'll make do. When it's -1, y would be 1/10. When it's 0, it would be 1. 10 to the first is 10. 10 to the second is 100. 10 to the third is 1,000. So that gets pretty big pretty fast. We're going to switch those in order to get the values for the log function. So when x is 1/10, y will be -1. When x is 1, y will be 0. When x is 10, y will be 1. When x is 100, y will be 2. When x is 1,000, y will be 3. And I'm pretty sure those are not all going to fit on a graph, but I'm going to do my best. Let me make my graph start here. It's going to go that way. 2, 4, 6, 9, 10, just barely. So when I go to plot the points, oops, 1, 2, 3, -1, -2, -3. Let's see, so I have 1/10, which is almost 1, or almost 0, and -1. I have 1 and 0 again. I have 10 and 1, and after that it goes off the page. So this one has the same basic shape as the one up above. It's just a lot skinnier, right? Because it goes a lot closer to the x-axis. We're still going to have an asymptote here. We can still talk about all the basic properties of this. Again, the domain in this, the x's are just greater than 0. The range is all real numbers because it goes down forever and it goes up forever. Now it's not going to get big for a very long time, but same idea. Vertical asymptote is at x equals 0. And our reference points this time are at 1, 0 and 10, 1. Okay, so that 10 is from the base being here, and 1, just like up here, our second reference point was at 2, 1. So that's the basic shapes. What we're going to do now is we're going to do a little transforming of those. So on to the next page, or perhaps the same page if you still have room on your paper. Questions, notes, and okay, so we're going to have another table that helps us find the information in order to make a graph. So this is graphing transformations of y, or f of x equals log base b of x. And just like before, our transformations are going to be a times log base b of x minus h plus k. Really important here that the k is on the outside of the parentheses. And the a, b, h, and k, they still have the same basic things that everything else has done. It's just going to be, they're just going to show up a little bit differently because the original graph was different. So the things we're going to have in our table, we're going to have asymptote, and we're going to have reference points. And just so we can compare it, here I'm going to do f of x equals log base b of x. That way for any other base, you'd also be able to find the asymptote. And then here, we'll do it for the transformation form. So this is when we have other numbers with it. We'll do examples. We did 2 examples of this already, but we'll do some examples of that later. So the asymptote, if it's just log base b of x, the asymptote is at x equals 0. Oh, I should have put in here that this is a vertical asymptote. So it goes up and down instead of left and right. So it's at x equals 0, and then the reference point here. Reference point is at, where was the first one? 1, 0. 1, 0 is always the first one, and B1 is always the second one. So as we start doing transformations, those are the 2 points that are going to move around. So when we have transformations of this function, instead of being at x equals 0, our asymptote is going to be at x equals h. And our reference point will move from 1, 0 to 1 plus h, k, and from b1 to b plus h, and a plus k. So you can use that table always to find your vertical asymptote and reference points, and then once you get those, you can draw the graph of your function. So for example, if you wanted to graph f of x equals -2 log base 2 of x minus 1 minus 2, so we'd look here at our table. I like to identify my a, b, h, and k first, because then it's just a little bit easier when I start plugging them all in. So my a is -2. That one comes from right there. My b is 2. My h, remember h lies, +1. And my k is -2. I have lots of colored pens open, and they're probably all going to dry out, but for you, it's worth it. So I need my vertical asymptote. My vertical asymptote is at x equals h. H in this case is 1. So that comes from my h. Now I need to find my reference points. So my first one is 1 plus h comma k, which would be 1 plus h was 1, k is -2, or 2 -2, and b plus h, a plus k. Well, b plus h is 2 plus 1. A plus k is -2 plus -2, so that gives me 3 and -4. Those are my 2 reference points for this one. So now I can draw the graph, and the graph takes a little bit of constructing, so we look at this and we look at this. I'll go ahead and start this here. Oops, excuse me for just a minute. Oops, sorry about that. Got interrupted, but you had time to draw the graph. So where were we? Vertical asymptote at +1. So at +1, I'm going to make a vertical line like so. My reference points are 2, -2, which is right there. Always remember they start from the origin, so 2, -2 would be there. And 3, -4 would be there. And then what you want to do, just like with the exponential functions, once you've got those 2 points, what you want to remember is it's going to curve in towards the asymptote. So in this case, instead of curving down towards the asymptote, because of where the points are, it's going to curve up towards the asymptote, like so. It's not going to cross the asymptote. And then on the other side, it's just going to shoot away. So for this one, our domain would be x is greater than 1, because that's where our asymptote was. It doesn't ever cross the asymptote. Our range is still all real numbers, because it's always all real numbers in these. Just switching them from exponential functions. Our axis, our vertical asymptote, we already found up above, but we can just write it one more time. And our reference points, you can see, are already there. I won't write them again for you. But that's the idea. It's using these formulas each time. Notice the formulas are a little bit different than they were for exponential functions, so it's going to be important to keep that in mind. And also notice that the domain is related to the vertical asymptote, and the shapes are a little bit different. They're either going to go or actually, let me just show you a whole bunch of different possibilities. So here is, this is log base 2, so this is the first example we looked at. So the first thing we can do is just start changing h. So changing h will move the graph back and forth that way. Let me slow it down a little bit. And you can see it just slides the whole thing left or right. So we can stop that then. Let's put that back to 0. So we can see what happens just when we change k. The whole thing just moves up and down. And the reference points, you can see, move along with it. So again, let's stop that and move it back to 0. And then where it gets interesting is where we start moving a. That's where it stretches out farther away. Or it could flip and go the other direction. So the graph that we just made is one that looks something like this. I could put in the exact values. The a was -2, the h was 1, and the k was -2. So you can see there it's got our reference points and our asymptote, and then if, you can move those around and see, but I just wanted you to see all the different possibilities. So you can have negative x values. It just depends on where your vertical asymptote is. That would be something that would have a domain of -4 to infinity. We'll practice more with that when you get to class next time. Thank you and have a wonderful day.